Right, this one's going to be about prime numbers, such as the Riemann hypothesis, to a lesser extent the Bircham-Swinton-Dyer conjecture, and a few other problems. Okay, so prime numbers, 2, 3, 5, 7, ad infinitum, can only be evenly divided by itself and 1. This is the simple description of prime numbers, I suppose. And the basic point of the Riemann hypothesis is, do the zeros within a certain definition of the prime numbers appear on a critical line or not? Forever or not forever, basically. So this comes down to a lot of the other fundamental problems about numbers. How long do numbers carry on for? Are there indeed a finite amount of numbers, as in a countable amount of numbers, no matter how big? Is it possible that we may be able to count them all, account for every single number, or not, basically? And as I've said before, there's three answers, okay? There is a finite amount of numbers. There's not a finite amount of numbers, as in there's an infinite amount, okay? And there's a neutral potential or point between the two answers as well. My main answer to the Riemann hypothesis is zeros are neutral. Zeros aren't 1 or less than 1, zeros are neutral. In between the point of being a number and not being a number, 0 symbolises nothing. I've also said that if the higher up you go in the millions, the 6 noughts, etc., etc., you get the more noughts you have, the larger number, but the more of nothing really, because 0 is nothing. So it just shows how abstract it gets at the higher echelons, I suppose, of numbers and things and study of numbers. And basically I've got a couple of people who seem to be debating whether or not numbers are indeed finite or infinite, specifically the prime numbers, on my Riemann hypothesis video at the moment. And of course the answer to the whole video is there's 3 potentials. People seem to be saying because of this idea, for example, whatever idea it may be, some evidence, there's definitely a finite amount of numbers, or numbers are countable, basically, is what they're saying. Or the opposite to that answer is another comment, and it says things like, oh, in fact they're infinite because evidence, 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 you see. Now the whole point of my video about the Riemann hypothesis and prime numbers is there's 3 potentials. As I keep saying, there's 3 potentials, and it's extremely simple, okay? So you've got a number, the opposite to a number, and the middle, which is neither the opposite nor a number. Okay, the same as everything else. Same as my hand, it's got a middle, it's got opposites, okay? Little finger and thumb, 2 fingers and a middle finger, okay, which I won't show you because it's a rude gesture. That's another story about the evil digit known as so from Roman times. But anyway, prime numbers, okay? That's the point. How far do numbers go, and at what point do we know that numbers go no further? And can we know such a point? Is there a point in the future in which we'll have super technology, supercomputers that will just be able to calculate every single number that's ever could possibly exist? I suppose that's the thing that they're asking. But if you think about numbers, okay, numbers can go forwards or backwards. You can have positive numbers, as in 1, 2, 3, 4, 5. Or negative numbers, minus 1, 2, 3, 4, 5, okay? So you've got the negative, the positive, and what do you think's here, okay? Right here in the middle there, it's 0, okay? So 0 is the beginning and end of all numbers in a sense. It's the point at which the negative become positive and the positive become negative, above and below, and in the middle is 0, as I say. So I'm providing 3 simultaneous answers to the prime numbers, really. I do think numbers are really interesting in everything. I think maths is great, you know, it's great fun and everything to study, but there comes a point when you have to realise that according to the theory of everything, or pro theory, whatever, there are 3 possibilities. So in reality, that there's never really going to be a singular and unchanging point at which we say, okay, we've calculated every single number, there cannot possibly ever exist a number higher or lower than this number, whichever number that may be, with loads and loads of zeros on it. I shouldn't wonder, perhaps 50 million zeros at the end of it or something. You know, that's how ridiculous it gets to, really. And the point is that numbers change. There's no unchanging amount of numbers that cannot be manipulated and changed. That's the point, really. So you look at the prime numbers and you think, oh right, you get into the higher prime numbers, such as when you're using computers and supercomputers to calculate the amount of primes or the amount of zeros on the end of a prime. And the thing is, they're never going to stop, I don't think, because numbers are made of three potentials. So I've said before, numbers either symbolise, one, the opposite to one, which is not one, which may be plural, or negative one, whatever, or neutral, which is zero, which is neither one nor the opposite to one. So think about that. They're the most fundamental, simple, beginning amounts of numbers from which all the other numbers are created. Every single number, no matter how large or small, is either one, singular, the opposite to one, singular, which is non-singular, or zero, which is neutral. Okay, so if we start with these like building blocks, okay, so we've got 1, 2, 3 in the middle, okay, and we build enormous amounts of numbers in the positive sense, or indeed the negative. It works the same, but the both ways, okay, because it's a mirror, basically. As I say, you've got 0 in the middle, you've got negative, and you've got positive. You've got negative and positive. 0 in the middle, okay, really, really, really simple. And we make these enormous numbers, such as, I can't think of a good example because it's too difficult to say on camera how many noughts there is and things, but imagine a number with 16,685 digits that's prime, you know, that kind of thing. This is the kind of thing we're talking about here with prime numbers and how far they can or cannot go, okay? So you think about these three simple amounts, repeat them, we get 100, 200, 300, and we go on and on and on and on and on. And then as we get into the highest ones where only the top experts in the whole world can sort of study them and even comprehend them, you know, and sort of imagine them basically. That's how it gets into an art form, you see, mathematics at its highest levels. It's like an art form rather than a calculation procedure, really. And numbers change, as I say, numbers are made of three repeating combinations. Just as I've said, one singular, the opposite to one non-singular, and neutral. So we've got these three potentials running through all numbers, no matter how large or how small. And then people are saying, it's this, singular. Which is understandable, but there's still three potentials within all numbers, as I've just clearly explained twice, you see. There's three potentials. Therefore, to answer everything, and nothing, and neutral, we need to provide negative, positive, and neutral. In the sense of mathematics, in the context of mathematics, this would mean we have to account for the possibility for there being one singular, the opposite to one, non-singular, and neutral, all at once, if we want to answer in the context of a theory of everything. If we want to answer everything at once. If we don't want to answer everything at once, that's fine. 2 plus 2 equals 4. As I've said the other day on the video, if we're in a shop or something, and it's 20 pence for a chocolate bar or something, then there's no two ways about it. It's 20 pence. If I gave them 10 pence and said, I'm inferring the opposite and neutral here, they'd be like, what? What are you on about, mate? And they'd probably call the police, yeah? Right? It's about context. Right? The theory of everything is a certain context in which we see things, in which we view the world, in which we view the universe. And that's the main thing that we need to realise, really, I think. As I say, it is very abstract in places. But it's about context. It's not about you must think in threes every day. You must think in threes like I exist, I don't exist, plus neutral. It's about the possibility that there is a possibility. That's the point. It's about it being possible. It's about what would happen if. You know, what if this, what if that? And it's about never leaving anything unanswered. It's about pushing it beyond everything that you've ever known and keeping going and keeping going. And it works the same, particularly with prime numbers as well. That's the most interesting mathematical application of it, I suppose. It's these three repeating amounts of numbers creating everything, every other number. Okay? That's the main point on that one, prime numbers. Like I say, I'm a bit off topic, but we'll see how we get on.